So this is a quick demo of the abstractive text summarizer that I've built here. So first of all, what technologies are we using here? Well, text summarization has been a very difficult task among the NLP community, and for a lot of time, it had been considered impossible to, you know, have a passage of text and then having a machine learning model to summarize it for us. But with the use of modern natural language processing technologies such as the attention based mechanisms and transformers that were released in 2017 and the um, BERT architecture that followed them, we have been able to get astonishing results in these text summarization tasks, along with similar problems in machine learning. So, what I've done here is that I have used the long short-term memory neural networks along with an attention-based mechanism to accomplish this task, and I've trained this neural network on the Amazon reviews dataset. So let's see how it works. First of all, if you are using this on Google's Collaboratory, then you will have to configure some stuff here. And if you're using this on your local machine, then you will have to run some other cells, which I'm going to specify right here. So this is a quick demo. I won't show you how, I won't go into depth, but if you are an experienced, seasoned machine learning engineer, then you will find this really helpful and readable. So let's begin. Let's import the files that we need. And before we even do that, we need to set some variables uh, so that things are easier for us. So if you are using Google Drive, you will mount your Google Drive here, and then you will change directory to wherever your project files are located. Then you will import these files, import these modules. So right here we are importing the attention layer. This is a custom attention layer, and you can find it on GitHub. uh, you will extract the attention.py file from that GitHub repository, and then you will be able to import the attention layer here. So let's run this. Here you go. Then we will import other libraries, and then we will read the dataset. Now for brevity purposes, let us only import 100 rows from here, even though they are uh, let me remember, I think 400,000 rows here, but we are only going to import 100 rows from over here. So let's go over here and do this, because there's an error here. TensorFlow.keras. Alrighty, and the stop words are not here, so let's comment this one. Here you go. So we read the dataset and we drop the duplicate values, and then we check data.info. After that, we do some data cleaning. Now I'm not gonna run these because it's gonna take some time. This is basic data pre-processing on text data. So we are removing stop words, we are cleaning out HTML tags, and we are stripping off spaces and unneeded characters. So yeah, that's about that. And we go down here and we see a summary of the maximum lengths that the summaries and the original texts are using, and from here we can calculate uh, where we need to cut the sentences short, because we are not going to be um, using long lengths of sentences and then padding with zeros the shorter sentences, because a more efficient approach is that we use the sentence length that is being used by most of the sentences. Uh, that logically is a far better approach. So, as you can see here, we've set the max text length to 30 and the max summary length to 8. We do some more data cleaning, add start and end tokens because they're needed. We create the test and train and validation splits in the data so that we can do model optimization and hyperparameter tuning. Alrighty, we use a tokenizer to tokenize the text data, and then we will be removing the rare words because this will make our approach more efficient. Then we will define the tokenizer with the most common words and with the rare words excluded. Then the summary tokenizer, and we find rare words for that as well. And then we fit the tokenizer and we convert the text, the original text and the summaries to vector data. Then we loop over the data to delete the rows that don't have um, text in them, that basically just have the start and end tokens. Then we build the model. So the model architecture has three LSTM layers in the encoder and one LSTM layer in the decoder. And just as usual, we have an embedding layer before the encoder and before the decoder. And we are um, going to attach the encoder and the decoder with an attention layer so that we can get some information about the context. Alrighty. Uh, Finally, we add a dense layer which is time distributed, and then we compile the model with RMS prop and sparse categorical cross entropy because we want to convert the um, vectors into sparse vectors on the fly so that we don't run into any um, memory issues. Then we set early stopping to monitor the validation loss and with a patience of 2 so that we stop training if we see that the validation loss is not decreasing for 2 consecutive epochs. Then we check the shape of all our data and then we train the model and we save the model. Now we do a bit of plotting and then we um, create some functions that will help us in our inference process, which are right here. Above that, we have the inference model, which is a slight bit different from the model that we had used to train. Um, it is different in that um, it has a set of input layers that connect to the um, inputs that we will be providing to this model, but the rest of the architecture is similar. It's using even the training models architecture because that's what we wanted to do. Next up, we will create some functions that will help us to convert text into tokens of vectors. Then we will finally see the model in action. So we run this cell and then we get the summaries. So first, this is the first review. Great, think might even better. Regular brownies, good, happy found. Now we've removed the stop word, so this might seem a little bit unusual, but this is the original summary. So good. And we can see that the predicted summary is even better. Great brownies. Well done. Next up, candies. Soft, soft peppermint means melt, mouth, bite, break apart, bad, sad, buy another kind, soft peppermint, next go round. Original summary is soft, predicted summary is not so good. and you can see the rest of the summaries that are here. Now, that's all for the demo. See you in the other model demos that I'll be creating. Goodbye. Have a nice day.